Yeah, so welcome to our YouTube channel. In this video, we'll continue talking about equilibrium in physics. So, in the previous video, we talked about the horizontal plane. Let's go ahead and talk about the inclined plane. So, here we'll talk about the inclined plane. So the inclined plane is something which is like this. Okay, so we'll consider this as our 90 degree. Then we have the angle here, which is theta. Then we have an object which is put like this. Okay, so I want you to pay much particular attention here. Now, what are we supposed to know? We already know that all the forces must be balanced. The force which is trying to move this object upwards, putting it downwards, moving it going to the atmosphere or downwards are all equal, because the object is not moving. It is at equilibrium. In this case, let's go and identify those forces. We have the center of mass, which is here. This one is the forward force. This one is the backward force, which can be the force of friction. It can be other forces. But we know that there is a force of friction. So we can label this as force of friction. Then from there, we also have the normal force. Now, be careful with the normal force. The normal force is always perpendicular to an object, or it can be perpendicular to the surface of the incline. Therefore, we are going to say, since the object is here, then it will form a 90 degree here and you form the normal force here. From there, apart from that, remember, we have another force which is weight. Weight is always perpendicular to the surface of the ground, and this is our ground. Therefore, weight will always be perpendicular. Then it will be pulling in this direction. Now, remember that our interest is always to find the forces in x-axis and y-axis. That is our interest. That is our interest. No matter whatever we have. So, this is what you have. In this case, let us identify the x-axis. So, the x-axis that we have is this one. What about the y-axis? The y-axis, since x and y will always be perpendicular to each other, then our y-axis will be this one. Therefore, we need to extend this line, because this one will come here. It will go straight, because our x-axis can't bend. It can't bend. So since it cannot bend, then it must go straight. From there, we can see that we have formed an angle between the weight here and this force which is opposing directly the normal force. So this is angle theta. Why? Because this angle is equal to this angle. After having this situation, then we are going to draw a parallel line to the x-axis. Where are we going to put our line from? We can put it either here or anywhere. So let us put it here. So this is our line. We can see that we have created our 90 degree angle here. Then from there, let us break the components of weight into x and y axis. Why are we doing that? We know that a certain component of weight is the one which is opposing the normal force. Therefore, we are going to use the Krieg ratios to break this down into x and y components. Now, to make things easy, let me just obtain this triangle that we have created here and draw it somewhere else here. So, our triangle is like this. So it is like this. Then we have our 90-degree angle here. Then we have theta here. Now, here we have weight. This is weight. Then we are going to label this side as our hypotenuse. Then we are going to label this side because this one is direct opposite to our theta. Therefore, it will be opposite side. Then automatically this one will be adjacent. Now, since we have understood what is going there, let us use the trig mnemonic to remember which trig ratios that we are going to use to find these two sides, because we are interested with the x-axis and the y-axis. We are not interested with weight. Therefore, we are going to say, since we have our mnemonic which is saying soccer tower. In this case, where so stands for sine, which is sine theta, which is equal to opposite divided by the adjacent. In this case, if we use sine here, we see that we have the opposite. We are also having our hypotenuse here. Therefore, the first trig ratio that you are going to use is sine. So we're going to say sine theta will be equal to the opposite over the hypotenuse, which is this one, which is h. Now remember that our opposite is in the x-axis. Therefore, this one is the same as the x. Then our hypotenuse is the value of weight. So this is the W. Now, assuming that we have weight, and this weight is the mg. Always, never, sometimes. Our weight is mg. Therefore, we are looking for x. Since we are looking for x, let us make x the subject of the formula. Therefore, we are going to say this is over 1, then we cross multiply. 1 times x, it will remain as the x, which is equal to sine theta multiplied by mass times the acceleration due to gravity. We are going to have mg sine theta. This is what we are going to have. Therefore, here what we have is mg sine theta. From there, let's go ahead and look for the adjacent. Now, which trig ratio uses adjacent? We have this one, which is cos. Now, if cos uses adjacent, let's see how we can use it. If we have cos theta, which is equal to adjacent divided by the hypotenuse, where the adjacent is the value of y in the y-axis. So we say y. Then the hypotenuse is the value of weight that we have here as mg. Then we are going to go ahead and make y the subject of the formula. In this case, it will be over 1. 1 times y is just y. So we will have y, which is equal to cos theta multiplied by mg, which will give us mg cos theta. Now, you can see that here, when we were dealing with vectors, in the x-axis, we were using cos here. But in this case, according to the diagram that we have used as our example, it has swapped. Sine is no longer for y, but it is for x. Take note of that. Take note of that. There is no any mistake here. So, we will put our mg cos theta here. Let's go ahead and correct our equations. In the x-axis, we have this force. We also have this force. Now, which direction is this force? This force is always opposing the forward force, so it is in this direction. Since the incline is facing like this, if the incline was facing in this direction, then we would have said this force is in that direction. Therefore, when we add this force and this force and this force, the answer is 0. Now, we know that we can say in one direction, since they are opposing each other, one is positive, the other one is negative. In this case, let us assume that the negative force is this side, then the positive forces are that side. Then we can add these forces. In this case, we can say negative of, open the bracket, the force of friction plus, because we are summing up these, they are working against this one. So plus mg sine theta cross, then this is positive, plus the forward force is equal to 0. From there, we can take the whole of this to the other side. Since it has a negative, we want it to be positive. Then we are going to have our force of friction as added to mg sine theta is equal to the forward force. In this case, the forward force is ma, which is mass times acceleration. Now, since it is not moving, we can just leave it like that. If you want, we can do the replacements. Now, when do we need to do the replacements? Usually, if the object is in motion and you are asked to find the acceleration. Take note of that. You will see how we can drive out the formula for acceleration. Hence, we will consider this as our first equation. Let's go ahead and talk about the equations in the y-axis. In the y-axis, we have the normal force and its opposing force, which is mg. So we assume that this is a positive, this is a negative. Therefore, we are going to say the positive mg cos theta minus the normal force is equal to 0. Then we can take the normal force to this side. Therefore, we are going to have mg cos theta is equal to the normal force. This is the equation that we have in the y-axis as our equation number 2. Now, let us play with the equations here. Let us play with the equations here. Remember, we said friction force, or the force of friction, is equal to mu multiplied by the normal force, which is like this. In this case, our normal force, according to the y-axis equations, it says normal force is equal to mg cos theta. Therefore, where there is normal force, we can go ahead and replace it by mg cos theta. Therefore, we are going to have the force of friction as equal to mu. So we have replaced our normal force by mg cos theta. Now, since this is what we have done, let's go ahead and get this formula and replace it here where there is the force of friction. Henceforth, we are going to have the new equation, which is where there is force of friction, we put this equation. So we are going to have mu, this is mu mg cos theta plus mg sine theta, which is equal to, this is the forward force, which can be replaced by ma. So we can put ma there. Now, you can see that we have our acceleration here. Since we have m here, we have m here, we have m here, which is mass, 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 mass. We can just cancel them out. We cancel them out. Therefore, we will have the equation for acceleration as acceleration is equal to mu g cos theta plus g sine theta. So this is the equation for the acceleration. Okay, so thank you for watching this video. It is part of the introductory videos on equilibrium, specifically looking at the incline or the inclined plane. Therefore, don't forget to hit the like button and subscribe to our channel for more videos. Thank you so much.